Good morning, everybody. Today I'm going to be doing something a little different with this video that I want to try out, especially since, for the most part, I've seen just about everybody's doing great on the IXL this week. You guys seem to be picking this up pretty quickly. If you guys learned it before, it's showing. If not, give yourself a pat on the back because it's been a good week. Anyways, what is the y-coordinate of the L circle? Let's get started here. Just keep the video short. So to find the y-coordinate of the L circle, we need to use what's called an x-axis, our x-axis and our y-axis here. Okay? The x-axis always goes horizontal, so left and right on the page. The y-axis, that's always going to go up and down. So if we want to find the y-coordinate of the yellow circle, you simply just need to look at where this yellow circle is on the y-axis here. So in this case, we see this yellow circle here is at y equal to 1. So you go ahead and type that in. What is the x-coordinate of the purple star? Well, we're going to look at our x-axis again, left to right. So we know that the x-coordinate will be over at 9, right here. That's where the star's at. And if you draw a line upwards from 9, you'll hit the star. Alright, so let's see, I'm looking for a little bit of a harder one, a little bit different. Okay, what are the coordinates of the purple square? Alright, so you need to remember when you're plotting x and y, order matters. When you're writing a coordinate, order matters 100%. And the way to remember the order is that, well, think about what comes first in the alphabet. It goes x then y, right? X, y, then it would be z. But x and y, that's the order they come in the alphabet. So down here, the first coordinate is going to be your x-coordinate. The second is going to be your y. Now, they're looking for numbers for this, though. So I'm going to erase that. They want to know what are the coordinates of the purple square. Well, we look for the x first. So we see that for the purple square, x is 7. So we type in a 7 here. And we see that y is 9. So you type in a 9. If you drew a line up from 7 all the way up here, over here to y, we get y is 9. And actually, let me show you that real quick. Try something out. Okay, so if I drew, we said 7, 9, so drawing up from 7 over to 9. Okay. And then we know that x comes before y, so our coordinates, we put the x coordinate first, which is 7, we put the y coordinate second, which is 9. So just remember that, x then y. I know maybe it seems like I keep bringing it up and you get it, but it is something students forget a lot. They forget this order, they mix it up. I see it. I've seen many high schoolers do that. So just, if you can remember this now, it's going to make your life easier, because you're going to be graphing for the rest of math, really. Alright, let's go to the next assignment here. Graph the points 1, 1, 6, 10 on the coordinate plane. This is very similar to the last one. We want 1, 1. Well, that means that when x is 1, y is 1. So when x is 1, we look at our x-axis, and then we go for when y is 1. So we look along our y-axis. So we have from here to here, 1, 1. And then we have when x is 6, y is 10. So we start off at 6 here, and then we go up to when y is 10. And if you drew a line like we did here, you're going to get something like this. So along our x coordinate is 6, our y coordinate is 10. And all these problems, these are same type of thing. So if you get this, if you get these first two, these were probably easy. So let's look at the whole coordinate plane now. So we need to, when you're working with the x and y axis, you're not just going to be working with the positive part of it. Now, I wanted you to get the idea of how to find coordinates in the first quadrant before we extend into the rest of it. So now we extend to the whole coordinate plane here. That's what you call it, the coordinate plane, or xy coordinate plane. And now we're going to do the same thing, except we're just basically we added negatives to it. So your x or your y coordinate might be negative this time. Now, just one thing I want to show you real quick. This was covered in the Math Antics videos, and I believe I posted a Khan Academy video on this too. But you're going to need to memorize this. In each quadrant, or each one of these sections here, is called a quadrant. We call this quadrant 1. This is quadrant 2, 3, and 4. And in quadrant 1, the x coordinate's always going to be positive. The y coordinate's always going to be positive. Right? Positive, positive. In the second quadrant, our x values are negative. So we'll put a negative here. And our y values are positive. In the third quadrant, our x's are negative and our y's are negative. So every coordinate down here is going to be negative. And then finally over here, every x is positive and every y is negative. So we'll do positive, then negative. Because remember, all of these, it's our x and our y, or x then our y, when we're doing our coordinate. And another word for this coordinate that you're going to hear, and I'll use this word as well, is ordered pair. I can type that out. Type it right here. Okay, so you'll see ordered pairs is another term for coordinates. So anyways, let's look at the y coordinate of the green heart. We're just looking for the y, so we go up to the green heart. That's 4. Simple. Let's go to a harder one. Okay, perfect. So if we're looking for the coordinates of point W, well, we need to look at our x first. So we go along our x-axis. You see that when x is -4, y is 3. And let's take a little clip here. So when we have x is, remember we're looking at our x first. You see when we have x is -4, we see that y is 3. And remember, we said in quadrant 2 that our x value is going to be negative and our y values are always going to be positive. It's always the case. Alright, if we wanted to find, let's say we wanted to find the coordinates of point x, well, it's the same idea. You would look for when x is -5, y is -5. So that would be point x here. The coordinate for that would be -5, -5. Alright, so let's continue on to today's IXL. So this is a way that we can translate this to the real world. Algebra goes hand in hand with the real world, things that we're going to cover, real data, like data that you might find, like what we see here. So if we want to graph this data on the coordinate plane, in this case, we're not really working with x and y, we're working with actual items. Now, these actual items can be represented by what we call variables x and y, and that's what you kind of see here, right? In this case, our x is the time spent watching TV in terms of hours. And then we see over here, our y is the number of episodes watched. So let me take a clip here. So what's going on is, in this case, this is our independent variable. Okay, so it's called an independent variable that goes along with x. That means that what we're doing is we're trying to see if we measure how much time was spent watching TV, then we're going to count how many number of episodes that goes along with it. So what I mean by that is if we spent 1 hour watching TV, that means that we watched 2 episodes of some TV show. So we can plot that where time spent watching TV, 1 hour, goes along with 2 episodes watched. So we'll do 1, 2. So we'll put a point right here. So on our graph, we'll put a point right there. Now, there's more to it though. We need to look at each column here. So the time spent watching TV, if we spent 2 hours, then we watched 4 episodes. So 2 goes up to 4. Get this. If we do 3, you go up to 6. 4 hours watched, that means that you watched 8 episodes. Goes right here. So each case, you can do the same method. It's always going to work when you're doing this. You just match up the x along the x-axis and then along the y-axis. Excuse me. So if you go ahead and graph it here, you're going to get something like this. And you would actually see, if you graph this as an equation, you kind of get a straight line through it. It's kind of hard for me to draw by freehand, but you can see how these would connect into a line. And that's something that we'll explore more later. It's something called a linear graph, kind of like what we were working with last week with proportional relationships. Alright, so let's do a couple more so that I can keep the video from being too long here. So let's look at this. So this is a table that's for somebody's allowance. It looks like if they complete some amount of chores, they get some amount of money for completing those chores. So we see that when we complete 2 chores, we're earning $4. So we see in this case, the number of chores completed is our x, our independent variable. So that means that when x is 2, the money that we get for those 2 chores is $4. So we do 2 up to 4. When we complete 3 chores, we get $6. So 3 to 6, right, match 3 chores to $6. If you keep going, you're going to see this is actually going to keep that same pattern here, right? Because for each chore, we're adding on $2. Just like when we were working with proportional graphs, right? If you actually continue this on, it goes through the origin. We said straight lines that go through the origin showed proportional relationships. Well, that's what we're seeing here. For every chore he's completing, he's earning $2 for that chore. Right? Every time we're adding one more chore, he's getting $2 more. So that means that we're adding 2 onto our y every time we're adding one chore along our x. And that's something that's we're gonna continue to see going forward and into 8th grade. You know, whoever your teacher is next year, whether it's me or Skariki or whoever, you're going to see that you're going to revisit this. And this is something, this has to do with the unit rate, constant proportionality, and it all ties together with a bigger idea, something very fundamental with at least introductory graphing, which is called slope. And that describes how this y is changing as x is changing. And don't worry too much about that right now. That is something that we'll talk more about later. So let's go ahead and complete this. Oh, okay. So I plotted too many points here. Right, I added in these extra points when I was talking. So just make sure you only plot the points they're asking for. So let's go here. This will be the last one I cover, and then we'll wrap up the video here. So charging Mr. Bell's cell phone battery. So Mr. Bell took some measurements. He said, okay, when I charge my cell phone battery for 20 minutes, it gets to 40% charge. Okay, so you go along, you say, okay, at 20 minutes, charges up to 40%. At 30 minutes, charges up to 60%. At 40 minutes, it charges up to 80%. And at 50 minutes, it charges up to 100%. Okay? So notice we get that same trend too. So don't plot them in here, but if you actually continued this, you'd see again, this is another proportional graph. We're seeing that every, let's see, looks like about every minute it's charging 2%. And let me show you that a little bit more. Oops. There we go. Okay, so remember, to find our unit rate, we can always take our y over our x, and that'll give us k, our unit rate or our constant of proportionality. Remember talking about that last week. Well, we already said in this case our time is x, our independent variable, right? We're counting how much time it is, and then once we count how much time it is, well, however it charged depends on that amount of time. So in this case, our dependent variable is the percent charged. So our percent charge goes along with our y. Okay, so we can put a y here, And to find this k, well, we see this is going to be a proportional graph, right? Well, to find that k, you would go ahead and you would take your y's divided by your x. 40 divided by 20 would give you 2. 60 divided by 30 gives you 2. 80 divided by 2, or divided by 40 gives you 2. 100 divided by 50 gives you 2. So that means that there's 2% charge for every 1 minute. But anyways, that's a little taste of what we'll get into more this year and next. So if you didn't get all of that on that last point I was making, don't worry, you're going to hear it again. So let's go ahead and plug that in. One last, I know I said the last one was, let's do one more quick one. So we have a smoothie recipe. We know that we can make, if we want to make one smoothie, we need 2 cups of almond milk, or if we want to make 2 smoothies, we would need 3 cups of almond milk. 4 smoothies would take, or 3 smoothies would take 4 cups. 4 smoothies would take 5 cups. Okay, so you go ahead and graph this. We get 1 smoothie goes along with 2 cups. 2 smoothie goes along with 3 cups. 4 with 3. Just like that. Just adding 1 each time. Right? Every time we add a smoothie, we're adding an extra cup. So that's the pattern we're seeing here in the graph. Alright, so I'm going to wrap up the video here. Hopefully you found this helpful. I might do some videos like this every now and then, just to keep it a little easier on me. PowerPoints can be a little time consuming to make, so I don't mind doing it, but I think something like this, just seeing the IXL right there, has its own benefits as well. So remember, our live stream is on Friday at 10 o'clock. Please try your best to be there. Bring a paper and pencil. We are going to be doing math. We're going to be doing practice problems. I think you're going to get a lot out of it. So if you felt like last time you didn't learn much, this time should be a little bit different. So please make sure you show up. And that's it. Thank you. Have a great day.